Old Faithful erupts again as thousands of earthquakes rattle Yellowstone. Scientists race to decode the unrest. Yellowstone National Park, USA, in the frosty early morning haze above the Upper Geyser Basin. A familiar roar echoed through the steam-filled air. Old Faithful, the world's most famous geyser, exploded skyward in a towering plume of boiling water and vapor. But this time, something was different. The eruption came immediately after a burst of more than 1,000 earthquakes that rattled the Yellowstone region overnight, a swarm so intense that even seasoned scientists admitted it was unusually energetic. For many visitors, the timing was alarming. For scientists, it was a puzzle and possibly a breakthrough in understanding how Yellowstone's vast and mysterious geothermal system responds to seismic unrest. A night of shaking beneath the park. Beginning just after sundown, seismometers across the Yellowstone Plateau lit up with activity. Over the next 14 hours, automated systems logged more than 1,200 earthquakes, the largest swarm in several years. Most of the quakes were tiny, magnitude 0.52 to 0.4, but their sheer quantity signaled rapid changes happening beneath the surface. Yellowstone Volcano Observatory scientists described it as a classic Yellowstone-style swarm, but with an intensity we haven't seen recently. Something moved, fluids, pressure, or both. Earthquake swarms are a defining feature of Yellowstone. They often occur when superheated water and steam migrate through the fractured volcanic crust, triggering bursts of tiny quakes as the underground plumbing system adjusts. But the timing, just hours before Old Faithful erupted, caught global attention. Old Faithful's timely outburst. At 6:14 a.m., just as the first sunlight hit the geyser basin, Old Faithful unleashed an eruption so forceful that rangers reported hearing the jetting steam before they even saw it. Tourists who stayed overnight at the Old Faithful and described the moment. The whole building trembled, and then we heard a massive whoosh, said one visitor. Someone yelled, "It's volcanology time," and we all ran outside. The eruption lasted nearly 5 minutes, longer than the typical 2 to 3 minute interval, and the water column reportedly soared higher than average. Cameras captured the event, steam rising in a glowing orange plume against the rising sun dot to the untrained eye. The eruption following a night of quakes looked like cause and effect.
And social media fueled the panic. Scientists step in. Panic versus physics. The phrase "Yellowstone is waking up" began trending online.
Photos, videos, shaky ground footage, and amateur predictions spread rapidly. The USGS, however, delivered a more grounded assessment. What could actually be happening? Hydrothermal fluid movement. Earthquake swarms often mean hot water or steam is pushing through underground cracks. This can temporarily alter geyser activity. Changes in subsurface pressure. Increased pressure may disrupt geyser intervals, pushing Old Faithful to erupt earlier, later, or more energetically. No signs of magma movement. Scientists emphasized that large-scale volcanic reactivation shows up as significant ground uplift, long-period volcanic tremor, rising gas emissions. None of these indicators spiked. Old Faithful is naturally variable, although famous for reliability. Old Faithful's eruption intervals have been changing for decades. Swarms can nudge its schedule, but it has deviated many times in the past. One USGS volcanologist noted, if Yellowstone were preparing for a major eruption, this is not how it would begin. What we're seeing matches fluid-driven activity, not magma intrusion. Still, even conservative scientists admitted that the swarm eruption sequence was scientifically intriguing. Historical context: when Yellowstone's geysers react to quiescence is not the first time Yellowstone's hydrothermal features have responded to seismic activity. 1959 Hebgen Lake earthquake and 7.3 Old Faithful's intervals changed. New geysers opened. Some old ones stopped altogether. 1985-1986 swarm, one of the largest recorded. Hydrothermal basins across the park showed heightened activity. 2000 to Denali earthquake, Alaska. M7.9 The shock waves traveled over 3,000 kilometers and still altered Yellowstone geyser behavior. These past events taught scientists that Yellowstone's system is highly sensitive, not just to local events but even to distant seismic waves. The latest swarm, though smaller than these historic giants, showed that Yellowstone's hydrothermal network remains intensely dynamic. A living supervolcano. Below Yellowstone lies one of Earth's largest active magma reservoirs, a chamber of molten and semi-molten rock feeding more than 10,000 hydrothermal features. Old Faithful is just one surface expression of this vast, boiling ecosystem. The recent events remind researchers how interconnected everything is. Earthquakes relieve or increase pressure. Pressure changes redirect fluids. Fluid migration affects eruptions. Eruptions release heat from deeper sources. It is this delicate interplay that scientists are racing to understand, not because an eruption is imminent, but because Yellowstone is a rare,
Natural laboratory for studying active volcanism.
What comes next? USGS scientists say they will continue
Analyzing the swarm's seismic fingerprints, monitoring geyser interval changes, checking GPS stations for ground deformation, sampling hydrothermal waters for chemical shifts. For now, the park remains open. Old Faithful continues its timeless cycle, and researchers are deep in data. But the night of shaking and the dawn eruption will likely become another chapter in Yellowstone's long history of scientific fascination and public fear. As one lead scientist put it, Yellowstone isn't waking up. Yellowstone has never been asleep.